Hello, bye. Alicia, you want to say anything before you go?
Hello, I'm Alicia. Have a good day.
Captain, my captain. All right, factorials. Now, you'll have to do this anyway, but have you done factorials?
Yes.
Oh, you're too good. All right, so we've talked about factorials a little bit. What is it? What is it? What is it? So 5 factorial, what would that look like? 5 times 4 times 3 times 2 times 1. Where do we find it on our calculator? Okay, option, more, probability, there she blows. Okay, so we know that 5 factorial, sometimes we won't even have to go to the calculator because it's one of those common things. It's almost going to be like a quarter. It's on vid, don't worry about it. All right, so we want to play around because it's a nice little skill to have. One of the big things that you must write down in your notes is that as much as we want to say, or if I asked you 0 factorial, we want to say, oh, 0 times anything is 0. 0 factorial is actually 1. These things. We? How do we simplify that? We want to say that it is just 9 factorial, so expressed in factorial form. But obviously, what is it missing? It's missing all the rest of the bits. So it's missing the times 6, the times 5, the times 4, the times 3, the times 2, the times 1. So because I want to write it in factorial form, I times it by that, and I'm allowed to do that. It's like if I times the top by 2, I can do it as long as I times the top, say that again. I can times the top by 2 as long as I times the denominator by 2. So we're going to do the same thing here. I'm timesing the top by all of that, but then I also have to divide by all of that. Do we agree? We? And lo and behold, what does this mean? What is 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1? I just wanted to say it. 9 factorial, and therefore the bottom is 6 factorial. All right, so exciting stuff, not really, but we need to make sure that we can do it. Same thing over here. How would I write this using factorial notation? Clearly the top line we really want to put 11 factorial, but to do that we have to write 7, and notice I am over writing 7 times 6 times 4 times 3. So you want to times it by, which is indeed 7 factorial. Would you agree? And I can do that. I can times the top by 7 factorial as long as I times the bottom by 7 factorial. What is this little sucker here? 4 factorial. So we end up, the top line is 11 factorial over 4 factorial times 7 factorial. Yeah? So we're not going to spend too much time on this. That's not it. Where did it go? Here it is. Okay, so we're looking at, oh, so close. I said 8. What did I say? 8B. No, I was wrong. It's 8C. Okay, you want to try and simplify these without a calculator. Brody, did you do these for homework? Oh, okay. You're looking bored. Evaluate, just so you can use your calculator. So everybody, 5 seconds. Off you go. Can we use our calculator? Tom, you weren't here. Ready? Here we go. You've got this. We go to option. Not here. We want more. Probability. There she blows. Factorial. And you can go, what did they ask us to do? 3 factorial. Let's go bold. 10 factorial. Want to have a guess? What do you think 10 factorial is? 1,000. Let's have a go. 10 factorial. Oof. Oof. Look at that. That is a mighty, mighty, mighty number. With 2a, we're saving our time here. So 2a, happy? That would be 4 factorial. 2b. Or not 2b, 7 factorial, right? What about C? That's when we do what we just did, timesy, timesy, timesy. Okay? But I'd hate for you to not be able to answer one of these questions? They're talking a lot at me. Factorials, its n is greater than 0. Greater than or equal to, greater than 0. Okay, so this one we would say, I want to write that as 8 factorial, right? Which would mean I have to times this by 5 factorial to get 8 factorial. Do you agree? And I can do that as long as I times the denominator by 5 factorial. We happy with this? So, do the same thing here. What would I have to times by? 11 factorial. So I have to divide by 11 factorial. So this ends up being 15 factorial over 11 factorial. Are we over this? Awesome. Now, do we have to do the rest of it? I really don't want to. Simplify without using a calculator, because then I'm going to put up the question that I got from Twitter. Yeah, I was very excited. My Year 12s liked it. That made them stop and think. They all went, oh, that's so easy. It's bleh. And they got it wrong. So then I said, no, let's think about it. And then, yeah, then they got it. But there, look, one thing, you could say one thing Twitter can be good for. Okay. What are they saying? Oh, all right. So here we go. Any ideas? Hello? Any ideas? More we do now, less you have to do for homework. So we've got, yeah, this is, do we all agree? Watching? Alex? This would be 7. 7 times 6 factorial, would you agree, is 7 factorial? We're just splitting it up. And so we're dividing. Why did I stop at that? Because I looked at the denominator, and as Dan V has said, they cross out, and bango, bingo, bob, I get. Yeah? Look at this one, 8 factorial. Well, this is 8 times 7 times 6, 5, 4, 3, 2, 1, which would be 6 factorial. Agreed? Dividing by 6 factorial, so they cancel out. 8 sevens, bang, bang, 56. Yeah, absolutely, check it. Don't just think that I'm giving you all the correct answers. Okay, who wants to deal with C? Go, Hames. Yep, we stop at 11 because then it is 10 because we're looking at the denominator. That's still there. That cancels. What's... Oh, is it? Yeah, 130. It has to be 2 because 11 11s are 121. So you've got to add on another 11. 132. My beautiful people. Okay, put your thinking hats on. What would you do for D? Do the 8. Do the 8. So it's going to be 10 times 9 times 8 factorial. Downstairs we've got 8 factorial times, now they're being a bit precious writing 2 factorial. I mean, come on. Why are we laughing and saying they're being precious writing 2 factorial? Yeah, because 2 times 1 is 2 factorial, which is just 2. So why have they put the 2? The exclamation mark. 2! But it's just 2 times 1, which is 2, not 2. All right, so are we happy with that? The 8 factorials will cancel. Yeah, how did you go 10 times 9 divided by 2, or did you go 10 divided by 2 is 5? 5 9s are 45. 10 divided by 2 is 5, 5 9s 45. Smaller numbers. So the hint for this is common factor. So Shriyash, we've got 53. Can't do much with that. But if I asked you, what is your common factor in the denominator? 51 factorial. So if we're going to pull out 51 factorial, save that, I can save that, 51 factorial, well, 51 factorial times what? Gives me 51 factorial, so 1. 51 factorial times what? Gives me 52 factorial. Wouldn't it have to be 52? So now we keep on going. We don't know what the answer is just yet. We look. and we go, this is 51. Oh, I did it again. 51 factorial times 53. Now, this means you have to understand what 53 factorial means. It means 53 times 52 times 51 factorial. Would you agree? So downstairs, what have we got? 51 factorial. Everything is times here, so what can I cancel out? Not everything. The 53 divided by 53, and of course 51 factorial divided by 51 factorial. I think this is such a neat little question. No. But isn't that cute? I found it on Twitter. List the different teams of 2 that can be chosen from a squad of 5 players named PQRST. Right? So can we list them? What are the different ones that we could do? So we could have, and this is really, I will make judgments about how you do your listing. So I would go with P, and that can be with Q, and then P can be with R, and then P can be with, then P can be with T. Then I go the next one. So now I've done P. Now I go Q. Now, with combinations, right, we're choosing this. QP is the same. We view it as the same as PQ. So that's already done. So now I go QR, QS, QT. Now I'm going to go R, but I've already got RP and PR. Does that give you shivers? RP, research project. And so we've got RP, have we got RQ? Yes, we have. Can we choose RR? No, So it's RS and RT. And so what's the last one? ST. So this, my friends, is combinations. Permutations means that we don't see, or we see that PQ is different to QP. And so we would basically, for permutations, we would have PQ, QP. We would have PR, RP, etc. So basically all of this, but we would times it by 2. And we said we don't want to, there'd be 20. How many have we got here? We said there was a bit of an issue. If we had to list them all the time, it would be nutso. And we might miss one. So we noticed on our calculator where we had our, right, we've got now PR, which was our permutations. So for this one, we are technically wanting a group of 2 from 5. So if we go over to our calculator, right, we go, pardon? How do you get this? We go 5, P, 2. Well, if you're listening to what I'm saying, I'm doing the permutations first because we didn't have people here last lesson. So that's how we get the 20, which we agree with. Yes? That's right. With combination, same sort of thing. We've got 5, but this time we are wanting to select a committee. I always like to think combinations as committees. So imagine if I'm wanting a committee of 2 from this class, Jazz and Amara. Well, it doesn't matter if it's Jazz and Amara or Amara and Jazz. That's a combination, right? So combination, I think committees, and that helps me go, the difference. Okay, and 2, do we get 10? Yes, we do. So do we see the difference? All right. I'm going to give you a moment to just digest some of this. This is the same. So combination, 5 from 2. Some people will get a little bit irritated writing combination 5, 2. I got to say, I'm not a fan sometimes of this because spec people. Vectors or matrices, yeah. And now that matrices and vectors, it used to be square. And now all of a sudden, if you look at the textbooks, we've gone Eastern State and they're now using these to represent. So now you've got to put it in context. Yeah, I old school, I did square. All right. So can we please just look at our... Thanks. I want you to use your calculators. Look at the answers that you get. It's not about, oh my God, I'm not doing this because I know where the button is. I just want you to take a little bit of a note of what the answers are, and then in a minute we're going to go, why? Why is it so? So absolutely, have a look at part A. It's just asking you to work these out on your calculator. Let's have a look. What do you get? So we're going to take NK, right? And we're going to just replace and follow our rule. So what would NK equal? N factorial. And I know some of you are going, really? I don't know really, because I just want to do the same thing but replace the R's with K's. Can't be that easy. Yes, it is. Right? NK, NR, we just replace the R's with K. So we go, that's K factorial, N take R factorial. We now look at the right-hand side, which is N take K. And once again, we're going to slap it into our formula and hope that it will equal this. We're happy with the top line. That's going to be N factorial. Everybody agree? Okay. In this case, what's my R? N minus K factorial. And now we have to go N, which is technically the top one, take the bottom one, factorial that. So it's going to be N, right? Are you watching the formula time of day? This says N take R, top take bottom. So what am I going to write here? N take bracket N take K. And lo and behold, what we thought looked like a disgusting question just works out beautifully. N take N, minus and a minus. I'll show you the inductions in a minute, kids. Restrictions will start off quite simple. Then they can get to a little bit interesting. I wouldn't even say they're complicated, so do not panic. So here we go. How many different teams of 3 can be selected from a squad of 8? So you've got 8 volleyballers. Oh, you can't have a team of 3, can you? Beach. Right, how many different, how many combinations or how many groups can we get if we had to choose 3 from 8? Again, where is the difficulty? Well, there's none. Because if there's no restrictions, wouldn't we just go C, 3 from 8? Before you use your calculators, have a guess. How many combos do you reckon? 27. Oh. Pick a number. 24. They're not playing the game. Right, let's do it on the calculator. What is it? 56. That's a wowzer. 56. Okay, so now, what do you think, without looking at the example, right? How many, or how's that going to change if the captain has to be included? So, my right hand, 1, 2, 3, 4, 5. Oh, we'll go here. 1, 2. Oh, he's not in it. 1, 2, 3, 4, 5, 6, 7, 8. Right. 1, 2, 3, 4, 5, 6, 7, 8. Please stand up. Please stand up. Please stand up. No. Okay. All right. Hamish, stand up. You can sit down. Seth, you stay. Okay. So, one of them has to, how many have I got to choose from? 8. But the captain, who's going to be our captain? Captain, no captain. Hamish, tallest one. He has to be included. So Hamish, Please sit down. How many have we got to choose from now? Yeah. So it's just going to be 7. And how many are we choosing? 2, because there's already 3 in the team. Now, technically, we should say, how many captains were we able to choose from? 1 and 1. And I like, you can sit down now. And I like to do this, because if I add up the top, 1 plus 7 gives me the 8. 1 plus 2 gives me the 3. And so I know I'm not missing anybody. But do I really need this? Because how many ways can I choose one person from a group of 1? 1. So I really know that's 1. Anyway, how much is it reduced by? What's 7C2? Oh, sorry, it's boring. Wow. I mean, are you surprised it reduces that by that much? Have I done it right? Yeah. That's a big drop, isn't it? As soon as you say this one person has to be included. Huzzah. All right. Are you happy with not much work to do? Come on, it's got to be good. Let's go. So no restrictions. We're just choosing 4 from how many? 13, right? 7 plus 6. So this will just be 4 from 13. Do we agree? Pop that in your calculator, write the number down. I think it's important to have a look at what the numbers are. Shows you the change, that the numbers that changes can make. All right, now, B, there must be 2 riders of each sex. So I need 2 from the men. How many men are there? 2 from 7, and I need 2 from 6. And of course, they're times together. So you pop that in your calculator. Now, when you pop it in your calculator, you can experiment if you want to. I always still put brackets around. Okay, so I will go, it might not matter, but I like to go bracket 7C2. Close my bracket. Times 6. I was trying to remember. Well done. 6C2. 315. How many were there with no restrictions? Ooh, just 700? 715. Wow. At least 1 rider of each sex is required. At least 1. So how are we going to do that? It means, that means you could have 1 male and 3 female. You could have 2, or you could have I'm struggling now, it's the end of the week. Yeah, easy. So I could do each one of those and add them up. Okay? So this would now be C1, 7, C6, 3 plus C7, 2 plus C6, 1 plus, oops, that should have been a times there, sorry, C7, 3 times C. Oh, I was going to say, I've stuffed up. Yeah, 1. What you want to look out for sometimes is sometimes instead of adding all of them up, you can do the whole take away from the whole amount, the opposite. But I don't think that would really work out in this case, would it? Oh yeah. What if you took only 1 sex from each one? So what if you went 1, all of them, right? So no restrictions. Take C7, 0 times C6, 4. What does that represent? What does this represent? No men, all women. And then we also minus, what would I do if I have all men? So what was all of them? 715. So can you pop these in your calculator? Do you get the same answer? I hope you do. I need a bigger page. Shh. Okay, I need you to stop talking and listen now. Lawrence? So, watching Pascal's triangle. We use it to help us expand things, and you are going to be doing this next week, right? Expanding. And this is probably the most algebraic section in the whole topic, even in the stats. And you'll be begging to do more of this. It's so good. Anyway, don't worry about writing this down. It's in your book. Here is the groovy thing. Can you grab your calculators? What if I wanted to, so this helps me to expand if I had something to the power of 4. This helps me if I had something to the power of 5 and so on. So what happens if I had to the power of 8 and you go, oh my God, do I have to draw the triangle every single time? Guess what? This one, work out what C30 is. Do you get 1, 3, 3, 1? What will this be? C40, C4, 1, C4. It all fits in. Like this is a different section, right, with expanding, but it fits in with counting and stats and probability. You don't care. Look at the faces. It's so cool. They're not impressed.